Okay, so welcome back. We hope you enjoyed your lunch. So we're going to begin one of two panels in this center meeting. And this is an important panel for many reasons. Not only do we have a fantastic set of panelists and our moderator who are going to share their perspectives, but there's been a lot going on in radio spectrum, at least in the US, but also around the world here lately. There's been a lot of talk of spectrum pipelines. We had one version of a spectrum pipeline, say, 6 months ago, and we now have a very dramatically different spectrum pipeline here in the US. And so we want to learn about that and figure out how SpectrumX should adapt its research projects around what's happening out there. So I'm going to defer to our distinguished moderator to introduce our distinguished panelists. Let me first of all thank them all for their time and their participation here today. But I'll start by introducing Julius Knapp. He probably doesn't need much introduction. He served for many years as the chief of the Office of Engineering and Technology at the FCC. And I've heard many people refer to Julie as a national treasure, which he, of course, blushes about and is a bit embarrassed about. But I think it's, having worked with him now for a couple of years as a very valuable member of our external advisory board for SpectrumX, I've come to believe that that is true. So with that, Julie, I'll hand it off to you and the panelists, and we look forward to learning from all of you.
Thank you so much, Nick. I watched the presentations this morning, which were terrific, and there were a couple of things that really caught my eye. One was the comment about having gone to Notre Dame University and seeing the buildings, which were described as very old and built in the early to mid 1800s. And so it made me feel young. And also listening to particularly the students. And I think back and I said, I started my career at the FCC when I was about your age. I was, I think, 22 when I started. And now I'm about 145. I worked through all the spectrum proceedings. So it really is great work that you're doing. And another thing that just struck me is that we often kind of see the trees instead of the forest. And so when you're working on something like spectrum sensing or advanced sharing techniques, and what you really can't appreciate at the time is how this really changes the lives of people here in the US and across the globe. In every sector, it's not, the immediate thing people think about are things like cell phones or maybe Wi-Fi, but it's so much more than that in every sector, from manufacturing and medicine, and even our automobiles today have got so much wireless technology in them, you don't even think about it. So everything you're doing is really important in the end. We have got a great panel. And I'm going to let them, after I do a short presentation on what people might think of as the pipeline bill, and they can say a few words about their thoughts on the bill, introduce themselves, say a few words on the bill, and or a little bit about spectrum policy generally for about 5 minutes each. And then we'll move on to questions, and I hope to leave about 15 minutes at the end for questions from the room or chat. So with that, Emily, if you can put up the slides. That is great. So, I've heard the one big beautiful act referred to in shorthand in a few different ways. Sometimes HR.1, sometimes OB3. The thing that really, I did a double take because the section that you're probably most interested in, at first I kept reading it as it was 4,002, and it's actually 40,002. So if you think some of the FCC proceedings are long, the fact that they even had sections numbered that way, there aren't that many sections in it, but I think they wanted to have some room for growth. So the law was adopted basically on July the 4th. And I've got the link if you haven't looked at it. And one key point is it renewed the FCC's auction authority through 2034. It had lapsed, I think, for a couple of years. And it established what people are referring to as a spectrum pipeline. It requires an allocation of 800 megahertz of spectrum, and this is important, for full power commercial license use cases for auction. And it actually gives a reference to the parts of the FCC rules that talk about full power wireless as the example of what Congress expects the bill to require. And the covered bands are frequencies between 1.3 gigahertz and 10.5 gigahertz. It specifically excludes 3.1 to 3.45 gigs and 7.4 to 8.4 gigs for purposes of auction, for reallocation, modification, or withdrawal. So those two bands were excluded primarily because of concerns about the impact on the Department of Defense. And it was part, as you might guess, a lot of these legislative acts are the results of compromises, and that was a key compromise to get the bill passed. So out of this, the Department of Commerce is to identify 500 megahertz from federal frequency bands within 2 years shall identify not less than 200 out of that within the covered band. One thing to keep in mind that it's not so clear as to what are exclusive. It doesn't use the word exclusively federal frequency bands because so much of the spectrum is shared already, between the federal side and the non-federal side. So, there's a little bit of sorting out as you go through that. And then the Federal Communications Commission, the FCC, is to identify 300 megahertz, including by completing a system of competitive bidding, i.e. an auction, not later than 2 years after the date of the enactment of the act, for not less than 100 megahertz. And it's actually referring to the particular upper part of the C-band. Let's go on to the next slide. I will tell you, first of all, what always prevails is the specific language of the act. So I've only cut out of here and tried to paraphrase in a simple way what the act does. But there's some other pieces in here that I didn't include just for sake of simplicity. But I thought it was interesting that it appropriated $50 million for the Department of Commerce to conduct analyses as required for the reallocations and to conduct a timely spectrum analysis of the following bands of frequencies: 2.7 gigs to 2.9 gigs, 4.4 gigs to 4.9 gigs, and 7.25 to 7.4 gigs. And by the way, as we were prepping for this, at first I looked at it and I mentioned to Paul, is that right, 7.25 versus all of the focus on 7.125? But apparently there was some method to the madness and not specifically mentioning that. The Commerce Department is also to publish a biennial report on the value of all spectrum used by federal entities that assesses the value of the bands of frequencies that they use in increments of not more than 100 megahertz, and not to include the bands that were excluded, the defense bands we talked about before. And I think we've got one more slide. Yeah, and then we had a few references this morning, I think indirectly to this first one. The FCC had released a notice of inquiry. For those of you who don't follow all the jargon of the FCC, what this is basically, it's asking a bunch of questions to collect information to figure out what, if anything, to do. And it dealt with the upper C-band, I just mentioned, 3.98 to 4.2 gigahertz. This is the docket number. That's a way you can look it up pretty quickly on the FCC website. and it was adopted on the 27th of February this year. So it was done before the legislation. So there were quite a few comments that were filed before the legislation came along. And then there have been additional comments where people have been coming in after the legislation was passed. And you can look at all of these comments and replies with the link that I've got there. And we'll probably talk about this a little bit more in the Q&A session. So the NTIA, or the National Telecommunications and Information Administration, which is within the Department of Commerce, had a Spectrum Policy Forum on September 10th. At that, Senator Cruz talked about how the bill came about and some of his thoughts about what he thought were the motivations and most important elements in it. And Assistant Secretary of Commerce for Communications and Information, Ariel Roth, spoke as well. 2 points that stood out to me, although there were many, was that she was going to send a letter to FCC Chairman Carr to identify the first 5 megahertz, and we'll be studying the 15 megahertz immediately adjacent to that. That spectrum will come from 1675 megahertz. I don't think she gave a boundary on it. Part of what's known as the L-band, and its reallocation will result in a win-win for the incumbent user, which is the National Oceanographic and Atmospheric Administration, the folks who have as their mission, and one of the main missions is weather forecasting and so forth, and a win for the American public. So NTIA plans to identify 4 spectrum bands in the range set by Congress. And those bands are 7125 to 7400 megs, 1680 to 1695 megs, 2700 to 2900 megs, and 4400 to 4940 megs. And don't hold me to it, but having been involved in some of this work in the past, there's a lot of weather radars in that 2700 piece. And there's a lot of stuff that, as spectrum was cleared from what had been federal allocations in the roughly 1.9 region, though many of those systems were moved up into the 4.4 region. So suffice it to say, none of these things are easy. It's complicated. So Assistant Secretary Roth said that NTIA expects to make progress on all 4 bands within a year and will exceed the requirement in the legislation to identify 200 megs within 2 years of July 4th, this past July 4th. And the other little thing that's going on is this preparation for the World Radio Conference. And what's key about that is, well, how does what the U.S. do fit in with what's going on internationally? And that too is a very complicated piece. Sometimes you might think to yourself, well, it's okay, for us to have something different from whatever might be in Europe or whatever might be in Asia. But it's a bit more complicated than that, because you start to think about the scale of production of equipment to operate across the globe and keep the prices down. So it's a multifaceted issue. I think the panel tomorrow, although focused on space, we'll probably hear a little bit more about the whole international issue. So that's the entire presentation. And so with that, I think Emily what I'd ask each of the panelists to do, and I'll do it in the order that they show, at least on my screen, to say a few words, their thoughts on the pipeline and spectrum generally from their perspectives, and try to keep it within 5 minutes or so. And Shawn, I'll put you up first.
Great. Thanks, Julie. Shawn Bone, Senior Director of Public Policy for Verizon. I've been at the company just over 4 years and came to Verizon after spending a decade on Capitol Hill working for Senate Democrats on the Senate Commerce Committee, where I used Julie's immense expertise more times than I want to admit on spectrum issues. So appreciate SpectrumX inviting me. Glad to be here. I'll actually keep my comments fairly short because A lot of what Julie just talked about relative to OB3 came as a result of a lot of conversation that the MNO community had with Congress about the need to, one, restore the FCC Spectrum Auction Authority, which, as Julie pointed out, had lapsed for a couple of years. So we now have a 9-year reauthorization of auction authority, which applies generally. You have the pipeline, but the auction authority is general auction authority. So there's a lot of work that the FCC can do with that general auction authority, even beyond what's there on the pipeline. And then secondly, we had argued for many years that it's important, particularly if you're going to do a lengthy reauthorization of auction authority, to sort of match that with a plan for auctions. So, in the wisdom of Congress, they put together this 800 megahertz pipeline, which now gives us the ability to plan against that for network deployment, network upgrades, and ultimately, the transition that everyone's talking about to 6G over the next, 7 to 9 years. So, this has been a lot of work by the MNO community with Congress to try to figure out the right puts and takes on this. The one thing I would say, sort of reflecting on WRC 27, is it's not, it's the bands that that Congress identified for NTIA to study were, they didn't come out of thin air. 2 of those bands match with what's on the table for possible IMT allocations at WRC 27. So we as an MNO community are pleased to hear that, Assistant Secretary Roth plans to move very quickly on those studies, because some of the timing in the bill didn't necessarily match with WRC 27. So we're glad that they're accelerating that, and hopeful that we'll get some output on those studies that will feed into the WRC 27 process. Broadly on spectrum, look, the wireless community for a long time has sort of stood on dedicated spectrum as the inputs into the network that gives us the control that we need to be able to deploy and tune the network to be as efficient as possible. I will point out, and I'm sure we're going to get to the conversation later on, Verizon has invested also in shared spectrum platforms. We're a big investor and user of CBRS. And I think we'll talk a little bit about the future of that band. I think broadly with sort of where we go from here on OB3, but this is for the MNO community especially, this is a welcome development out of Congress, and now we're sort of shifting to implementation.
Great. Thank you, Shawn. Mark, I think you're up next.
Okay. Well,
Mark, okay. You got
sorry. Took me a second to get off mute. Thank you, Julie, and thank you for the opportunity to speak here today. And I think the overview you provided of the bill really sets the stage. So I just want to take a few minutes, less than 5, to share how we think about sort of spectrum policy and sort of wireless connectivity more generally. And even before I dig into that, for those that are not familiar, Cable Labs is the R&D lab for the global cable broadband industry. So we are here to sort of help develop the network technologies for those future networks. And part of that is that we have to think about sort of what does connectivity look like in the future. And we often talk about spectrum policy as if it is sort of an end in and of itself. But as Julie highlighted earlier, the end isn't sort of allocation. The end is the uses of spectrum. It's connectivity for consumers, businesses. It's the medical devices that he described. It's all these uses. So spectrum policy is a means to push those applications and push those services and deliver those services. So when we think about the future of connectivity, we think about seamless and ubiquitous connectivity. And the question then becomes, how do we deliver that to consumers, to businesses, to enterprises? We think about that across sort of layers of connectivity, and using those sort of multitude of access network technologies, integrating them together to provide that seamless experience to the end user, where we are delivering sort of the connectivity from a performance perspective that they need and want wherever they are and where they are. So how do we do that? So it's about those layers of connectivity. And we really think about 3. We think about Wi-Fi being that sort of inner, most intensive use of connectivity, whether that's at home, whether that's at the office. Wi-Fi is the workhorse of the internet. If you think about your smartphone, roughly 80 to 90% of the data used on that smartphone is offloaded and delivered via Wi-Fi, sort of full stop. And then, so that's sort of that innermost intense layer. Then you get to the second layer, which is the terrestrial mobile network, sort of what Shawn was describing. It's a critical layer. It enables mobility. It enables that high throughput, high usage while you're on the move. But the third and sort of emerging sort of access network that really allows us to have that coast-to-coast coverage is the rapid emergence of these LEO networks, non-terrestrial networks, direct-to-device networks. And that, we can, I think, declare that we have universal coverage now. You couldn't say that before. And that will change the game as we think about applications of the future, where effectively anywhere on Earth, you can now have connectivity. Can it provide capacity, sort of where you have a high density? No, that's not its purpose. It's sort of to provide that universal coverage. So you should think about these as sort of three legs to a stool. And unfortunately, OB3 really addresses just one of those three legs. And I think we really need to think about OB3 too in the context in which it was produced. It was about generating revenue for the federal government. And, you look in the statute, and one of the requirements is to sort of maximize net revenue through auction. So as much as it is about spectrum policy, it's really about driving revenue. So when we think about that bigger picture of connectivity, we need to remember that it is not sort of just solely about sort of terrestrial mobile networks, but that broader sort of three legs that's going to provide sort of ubiquitous, seamless, high-performing connectivity for sort of all users and consumers. So with that, I'll stop, and I know we're going to dig into a lot more issues as we go through, but just wanted to introduce with that.
Thank you, Mark. I think I'm going to just flip one thing. I'm going to go to William, and then I'll go to Paul last. And hopefully I haven't caught you off guard,
No.
but go ahead.
Absolutely fine. Thanks, Julie. So as I'm sure you can all detect, I'm not from the US. I'm based in the UK. I'm an engineer by training. I've spent 30 years or more now working on or around the radio spectrum issues. I was at Ofcom, the UK equivalent of the FCC, for 7 years. And then I did actually spend 3 years in the US working for Motorola around the turn of the century. And since then, have acted mostly as an independent consultant on a lot of these kind of issues. So not being from the US, I'm going to kind of take a bit of a step back and look at the bigger picture. And I have to say, all my experience over time of spectrum pipelines in the US and other countries is that they have all dramatically under-delivered against the promise that they had. Essentially, they've all been broadly failures for a range of reasons. And the main one is because they tend to decouple supply and demand. Suddenly, you just say, hey, well, let's have 800 megahertz of spectrum. Why 800? Where did that number come from? What's the demand for it? And in what bands does that demand arise, or what kind of spectrum is needed? It's to just throw out a number and just throw it out there tends to result in a bad mismatch between what's actually delivered and what's actually wanted. And what often tends to happen is, of course, it's easier to free up more spectrum on higher frequency bands, so it tends to bias the response towards delivering higher frequency spectrum, which is generally not a good thing. We've seen how that's gone with the millimeter wave stuff for mobile connectivity. And so anything that biases people towards a higher band will generally result in a less good outcome. Also, as Julie, I think, mentioned, and a few others have, it's really, really helpful to have global harmonization. It's helpful for equipment supply, for moving around the world with hand portables, all those kind of things. And to decouple from that process makes the spectrum less useful and eventually potentially useless if the device manufacturers don't decide to go down there because there's just not enough demand. And again, the pipeline approach runs the risk of moving away from global harmonization. Not completely, it doesn't have to be a disaster, but it does put that relationship onto tension. And then the last thing I'll throw out there is some of you may have been aware I've been doing some work in the last few years looking at the growth in data demand on both fixed and mobile networks. I wrote a book last year called The End of Telecoms History, which showed that essentially our rate of growth of demand for data is slowing substantially and is likely to tend towards a plateau in the next few years. And if that's correct, then we won't need a lot more spectrum anyway, because the primary reason for spectrum is to drive more capacity into the network. And again, that doesn't seem to have been factored into any of this kind of thinking. So I'm dubious at this point in time that this is going to deliver a good outcome, but it would be great if there were a way through all those issues that could be charted to end up with something that really was a happy output. Thank you, Julie.
Yeah, thanks, William. Before I get to Paul, I just want to explain to people who may not really know how all these pieces fit together and work. So, technically, the FCC has got jurisdiction over the public sector, the public's use of the spectrum, and as well as public safety. That an NTIA is responsible for spectrum management on all of the federal side. So the two pieces have to work together. That happens in a number of ways with dialogue between the NTIA and the FCC. And these problems are hard, and it might not surprise you that sometimes there are disagreements between the federal side and the non-federal side, and the job of the agencies is to sort through those things. And of course, working, the tasking is answerable to Congress. So Paul over there in NTIA, they got a great group of people, respect them all. And now they've got a real challenge in trying to figure this out. And if you think it's easy, talking to agencies that are passionate about their missions, understandably, whether it's air safety, national security, transportation, they're deeply committed to their missions and they rely on spectrum. So NTIA's job is tough on both sides. On one end, they have to work together with the FCC. On the other hand, they've got to kind of work through with all of the agencies and DoD to come up with the path forward. And with that said, I'm happy to introduce Paul Ransom from NTIA.
Well, thanks, Julie. Can everyone hear me? Great to be here. Starts off really well. I really enjoyed everyone's comments. I think they're perfectly in line. And to Julie's point, I'm the acting chief of the Strategic Planning Division in the Office of Spectrum Management at NTIA. And NTIA is the principal advisor to the president on telecom policy. And we have another responsibility, which is to present the executive branch view on telecom policy to FCC. So Julie talked about it. We work with FCC a lot on telecom policy, spectrum management policy, and our job is to present the executive branch view on all policy matters related to spectrum to the FCC. And as a president principal advisor on spectrum policy, we're led by the Assistant Secretary of Commerce for Communications and Information. And Julie pointed that out. That's Ariel Roth now. She was nominated in early the summer, I guess a midsummer timeframe, and then confirmed in the fall. So she's been on board for maybe 3 months now, maybe 4 months. And at NTIA, we essentially have kind of 3 core responsibilities or missions. So our first mission is we manage federal spectrum. So as Julie noted, spectrum is allocated as either non-federal allocation for spectrum through the table of allocations, or it's allocated as federal spectrum, or it could be a combination and shared spectrum. So, and the FCC manages the table of allocations for domestically. So they are responsible for making allocations. They're responsible for reallocating the spectrum. NTIA provides the executive branch view and then the FCC allocates the spectrum based on that that view from the federal government. And so, in managing federal spectrum, essentially we authorize the use of spectrum for the agencies. So if you think about certain, there are critical systems that utilize spectrum. Obviously, you have airport radars, you have weather radars, you have Earth exploration services, and space research and satellites. So in order to operate those particular systems, you have to receive what we call a frequency assignment from the NTIA. An assignment essentially is a reservation to use a specific band of frequencies in a specific area for a certain set amount of time. And so we coordinate this entire process through something called the Interdepartmental Radio Advisory Committee, or the IRAC. So every agency that uses spectrum is a member of the IRAC. And the FCC attends the IRAC in an observer role. And so we support the frequency management of spectrum through the IRAC. In addition to providing these so-called frequency assignments, we certify the particular systems that operate in the bands. So you get a frequency assignment as an agency, and then in order to operate certain equipment, you have to conform to the frequency allocation. Again, going back to the table of allocation. So, for example, if you're going to operate a drone in a band of allocated frequencies, can't operate that drone and say a band that's allocated for a fixed service, say like a microwave links. So that entire certification process is also kind of managed through the IRAC, and it ensures that these systems don't experience harmful interference. Kind of the second core mission responsibility of the Office of Spectrum Management is to conduct these so-called electromagnetic compatibility studies. So this is a major part of what's in OB3. The Assistant Secretary has been given the responsibility to conduct a feasibility analysis. And the Congress identified the 3 bands that Julie outlined earlier to conduct these studies. When the Office of Spectrum Management, we lead the studies for NTIA, and we work with the agencies to kind of determine how we would make the spectrum available, and if we can make the spectrum available. And to Julie's point, as you conduct these analyses, you have to, the agencies have critical missions for which they need spectrum. And, as you're doing this analysis, you have to ensure that those missions are protected. And how you decide to make that spectrum available, it has to support those missions. And we still have to be able to, achieve those missions successfully while trying to make as much spectrum available as possible. What's interesting is, as a part of what's in the statute that is a part of the NTIA Org Act, is that when we conduct these studies, Congress has told us to prioritize so-called relocation or providing exclusive use over shared use. So wherever possible, Congress has said, make spectrum available for exclusive use and your conduct of these studies. Now, if you cannot do that based on the technical mission doesn't support it, or there are certain cost constraints, then you look at, approaches, kind of sharing the spectrum. But, we have those things outlined in statute. And, as we conduct these studies, this is how we look at, trying to make spectrum available. I guess the final kind of key responsibility for the Office of Spectrum Management is leading spectrum management policy for the executive branch. Talked about it earlier. As NTIA provides the executive branch view on spectrum, that includes obviously spectrum policy. And so, Julie talked about it. There are 4,000, this is section 4002 of the One Big Beautiful Bill Act. We typically are able to kind of weigh in and provide what's known as technical assistance to Congress as they are drafting these bills. So Shawn talked about that the MNOs worked with, Congress about, what they need and what would be helpful for spectrum policy. And Mark talked about, hey, it's not just about, terrestrial access to spectrum. There are, other ways in which we can fulfill the needs of the nation. Well, at the Office of Spectrum Management, and particularly within the Strategic Planning Division, Congress asks us for technical assistance as to, what are the kinds of things we should be thinking about as we start to kind of write spectrum policy. And, that's another kind of key part of what we do in the Office of Spectrum Management, providing that kind of technical assistance and, kind of leading spectrum management policy for the executive branch. I don't know. I don't want to go over my 5 minutes. I will say I'm very much looking forward to the conversation. I think this is going to be a very fun panel for everyone. I hope everyone enjoys it. With that, I think I'll go back to Julie. Thanks.
Thanks, Paul. So let's go through questions, and I'm going to do my best to see that we're out of the my questions by, let's make it 2:25 or so. I want to leave enough time for questions from the audience. So the first is, how do you envision the role of the 800 megahertz for licensed full power spectrum in introducing what I thought of as there's one motivation was 6G and AI and the United States leading in those areas. But obviously, when an auction is conducted, it's not, in general, the FCC provides flexible rules. You can introduce any top technology you want within the existing bands. So even though I talked about CG, what do you envision to happen there? What kinds of new applications would you think we'll see? Thoughts, comments?
I mean, I guess I'll jump in to start, Julie, and then I'm curious what others have to say. I probably won't comment on the application thing because we provide the connectivity to power the applications. We're always interested in what people do with our connectivity, and that's maybe there's plenty of fun entrepreneurs in the room right now who will come up with great uses for the capacity that's going to come online. But when it comes to how do we see the 800 and what are we thinking about as an MNO as we look towards this sequence of auctions over the next 9 years? I think it comes down to two things for us. I mean, the first thing is we are still seeing capacity demand increase on our network on a year by year basis. I can show you, CTIA figures showed, we're at 139 trillion megabytes running over terrestrial mobile networks on a yearly basis as of 2024. That was 39. That was an increase in 39 trillion megabytes on a year-over-year basis from 23. Verizon's figures were growing at anywhere from 20 to 30%, depending on the market, each year. So, we are looking at adding capacity to the network on the immediate term. And that's also reflective of what fixed wireless, frankly, is bringing into the system, and the fact that, that has been shown rapid growth in the fixed broadband market. And for those who aren't familiar with it, fixed wireless is the use of the terrestrial mobile network to provide home broadband. And what we do is we use the same, 5G spectrum that we use for mobility, but it connects to a home router and can replace a wired connection for some consumers if they, find it competitively better from a price point, or it can provide new connectivity in areas that didn't have it before, or we're stuck at a DSL or possibly a a GSO level LEO service. So that's sort of this immediate influx, that we're looking at with the extended C-band auction, the first auction you mentioned, and possibly others in the immediate term. That's probably what we're looking at more than anything. And then, there's going to be probably a delay as we figure out, as NTIA finishes the studies, that we figure out what the next round and, incorporating what happens at WRC and everything like that. And that sort of second wave of auctions will be capacity on the network for sure. But I think those are the bands that we're looking for that will be sort of the foundational bands for 6G. And I think what you saw in the passage of the OB3 and the conversation you saw from Administrator Roth afterwards was, I think the government is focused on the geopolitical question of 6G. There's been sort of this throughput line from 5G to 6G about the need for the US or the US and US allied countries to make sure that we're creating the uh, technical ecosystem for 6G as opposed to, say, China or others, and you can continue to sort of use that once you've got the networks. The claim is then you have the applications built on top of it and you develop the ecosystem. That was the story from 4G, where you had the 4G transition in the US first, and then you had the entire sort of mobile app economy ecosystem built over the top of it. But from the MNO perspective, we're sort of thinking at it, in both ways. It's the capacity sort of additional layers, and then it's how do we get to 6G in a time frame that matches up with the standardization cycle, or tries to match up with the standardization cycle, and sort of the larger international decisions being made on the right bands for a 6G transition.
Great. Thanks, Shawn. Anybody else on the panel?
Yeah, I'm happy to jump in there with perhaps a bit more of a global perspective. So I think at the moment, 6G is very uncertain as to what it's going to be. It's really unclear what direction it's going to go in, what needs it's going to meet, what it's going to look like. And what we see around the world is that the most MNOs are saying that they want 6G to be software only. And they said that individually, and they said that collectively through the industry bodies that they pull together for that. And of course, software only means no new frequencies, because you can't add new spectrum to a base station just by software. You have to add the antennas and the RF components and everything else. So I think around the world, the majority of mobile operators are not at this point in time looking for new spectrum for 6G. And instead, they're expecting that they can run 6G on the bands that they currently have, that they use for everything from 2G to 5G, in the same way that 5G was deployed in some cases on 4G bands using the dynamic spectrum sharing picture. So it may well be we don't actually need any new spectrum for 6G, that it's actually deployed within the 5G spectrum, or the spectrum that's sort of gradually expanded to include that. If we do need it, then we need to look carefully at what 6G might be. And for example, there's been a lot of discussion about whether it should include integrated sensing as part of its capabilities, a kind of a radar-like capability. If you want to do that and do that well, you need very high frequencies to deliver very precise positioning. So if that were a direction for 6G, then you'd want to be looking at millimeter wave bands and things like that as part of the key part of it. So I think it's actually quite dangerous to just say, here's the pipeline that must surely fulfill all the needs of 6G at this point in time. It needs a lot more careful understanding of where that's going and what that might be.
Great. Thanks, William. Mark, did you or Paul anything to add?
Yeah, just real quick. I wanted to double down on some of what Shawn said. To be blunt, the killer application for 5G was fixed wireless access. Like, that's where they generated real, the mobile operators generated real additional revenue and really started to be able to justify the investment in 5G. For fixed wireless access, it's been great for consumers. It's provided sort of competitive alternatives to wired fixed broadband. But, from a spectrum policy perspective, it seems like a bit of a miss, or, it doesn't quite fit, in the sense that, we're thinking about spectrum for purposes of mobility, but the killer application was actually this effectively point-to-point service. You're using the mobile infrastructure to deliver a point-to-point service. So, I think we just need to be careful about how we're thinking about this. And I think the point that William made about, sort of 6G, 5G, 4G and the transitions, you think about how consumers think about 5G. They think about it as effectively incremental improvement from a mobility standpoint, from 4G. And it's not clear yet if 6G is just going to be sort of incremental improvement over 5G. I think the real question is always like, where's the money? Like, these are going to be huge investments. And if you look at telecom sort of revenue growth globally or in the US, it's like small single digits at best, from an industry perspective. So how do you justify huge CapEx, whether it's acquisition of additional spectrum or, all the equipment that will be needed, very expensive equipment needed to sort of bring online, particularly higher frequencies, and even things like ISAC. It's not clear yet what the monetization or product path is to sort of turn that sort of technology into new additional revenue for the industry. So, and lastly, just on AI, I think it's still interesting question as to whether AI will, one, generate meaningful new traffic for sort of residential consumer use. Obviously it's generating huge traffic in the data center sort of space, but how does that translate to consumers? Not quite clear yet. But even if it does generate a lot of traffic, largely that'll be, moved via Wi-Fi, within the home, within the office, much like today. So I'll pause there.
Thank you.
Julie, I'd just say, Congress did identify, particularly where this 800 megahertz is going to come from. The covered band is 1.3 L band up to 10.5 gigahertz in X band. So, at this point, Congress has said, hey, we think we need 800 megahertz in mid-band to upper mid-band spectrum, which is where, the focus is now. Not sure if that's limiting, particularly what 6G applications could, be utilized from this particular kind of spectrum effort that's ongoing. But certainly that's where we're, focused all of our energy now, at least for this new spectrum pipeline. Just wanted to outline that, highlight that.
Thanks, Paul. And I suspect we could probably use the rest of the time to talk about this one topic. But and the other thing for the students that you'll find is that in the area of spectrum management, everybody agrees on everything all the time. So let's move on to a frequency band that I think is front and center immediately, and that's this upper C band, 3.98 to 4.2 gigs. I mentioned that the FCC had gone out with this notice of inquiry. And as you probably know, first of all, this all came out of what was satellite C-band, fixed satellite service. And I must confess that when I first saw Congress pass a requirement to conduct a study of that band, I was surprised that the satellite industry ever let that go through. And, there was a lot of discussion about, okay, how much spectrum might be recovered. And there was a lot of debate about it. And, so a big chunk of it was basically repacked. Some got out of the business, et cetera, et cetera. So when that happened, I still remember it was in the holiday season, and I'm retired, and I turn on the TV and hear that airports are shutting down service, et cetera, et cetera. And I'm like, oh my God, what happened here? So after a lot of pain, I think all ways round, for people who had bid and won license in an auction and suddenly found, they're up to this major, if nothing else, public issue, which is not to say it wasn't a technical issue. Took a lot of work for people to sort it out. So when I saw the NOI, my first reaction was, oh my goodness, I sure hope people have already, been working on this. And from some of the comments that I think all of the key players have made lately, the wireless industry, the FAA, the aeronautical industry, NTIA, there seems to be a lot of good work, optimistic about being able to have the two be compatible. Probably still some debate about how much of the spectrum can be repurposed for full power wireless. Obviously, I think the folks on the wireless industry side would like to have it be as much as possible. I think on the aviation side, they just want to make sure that their mission of protecting air safety is fully accomplished. So with all that background and said, and recognizing this is still an open issue, any thoughts or comments from our panel on that?
Yeah, look, I could mic drop and say, yes, we're talking and just leave it there. But to give you a little bit more flavor on that, there's a number of different conversations going on. And I think we all, the MNO community and the airline community and the FAA and the FCC and NTIA, I don't want to forget them as well, all learned a lot of lessons from the first time around on C-band. So there's been a very deep ongoing dialogue, both at the engineer level and at the policy level, about how we make sure we don't have the same challenges this time that we had last time. Nobody wants to go through the experience. I joined the company 1 week before, I believe, people started to talk about airplanes falling out of the sky. So you can imagine what my first few months at Verizon was like. No, I think to your point, Julie, there's a lot of good work going on between the engineers on all sides on how do we figure out that right balance between additional spectrum for mobile wireless connectivity and making sure that there's sufficient protections on the other side for altimeters, and frankly a recognition that there may need to remain some satellite operations in the C-band to satisfy the video programming delivery and other things that the C-band satellites have done for a very long time. Yes, you are correct. We would like to maximize the amount, but I think we're trying to be realistic in the conversation. I think the flip side of this is not every part of determining what will get reallocated and how that will happen is strictly an engineering question. There's a lot of policy questions that are embedded in that, not from the new altimeter standard that the FAA is expected to sort of adopt as part of this process to figure out how they're going to, make better altimeters that have better, the ability to reject spurious emissions from 5G and what the cost of that will be, what the timeline of that will be. And doesn't even touch the satellite questions as well. We expect that the FCC will kick off a proceeding soon-ish, pending government shutdown issues, to open up a lot of those questions, sort of following on from the NOI. But, we are doing a lot of work now to figure out what that right number is, how we make the engineering match that number, and how we make sure we don't have a flare up over Thanksgiving and Christmas, because my family really likes to see me at home during the holidays.
And Mark, maybe you want to say a little bit about the incumbency, and thanks, Shawn, for touching on that base as well.
Yeah, no, so right. I think a lot of the press and airtime goes to the altimeter issue, but that's not the sort of only issue in upper C-band. The video distribution links, the satellite links that were alluded to, are very much still used today, particularly in rural and isolated areas. Like, that's how video content is delivered to those areas. So as we think about how to address the various incumbencies, there are a multitude here. So obviously the altimeter issue is super important. I can't emphasize that enough. And it's often where you would expect there to be a high density of devices and users. Airports are typically around big cities. And so there is a sort of a confluence of sort of higher usage, 5G or eventually 6G usage, and those altimeters sort of geographically. When we think about the video distribution, particularly in those rural and isolated areas, perhaps there is some sort of geographic separation that makes sense. I don't want to get ahead of myself here. I don't know where or what the best solution is, but you could see there's just sort of potentially a difference in density of usage in those areas from a 5G, 6G perspective than around airports from a 5G, 6G perspective. So maybe there is something there. Also, just one point on the altimeters, and I am not involved in this issue at all, but I'm hoping as they look at altimeters, they are looking at it symmetrically. Like, obviously, the question is around upper C-band today, but if there's going to be use above the altimeters in 4.4 or lower 4, if you're going to rework those altimeters, let's just do it once and make sure we got them protected on both sides so that we can introduce other services later down the road above them as well. So I'll stop there.
Yeah. Paul, did you want to say something?
No, I think Mark's absolutely right, though. I mean, above 4.4, you're looking at, potential access to spectrum there too. If not exclusively use, but certainly seeing if there's a way to get kind of more intensive use of that spectrum. Is there a way to, perhaps do other things in that spectrum? So certainly being smart about how you make these investments on, upgrading altimeters and the front ends to ensure that, they can reject and have some resiliency to out of band emissions would be, something that would make a lot of sense at this point. So certainly, I think that is something that folks are very much aware of.
Yeah, I would just add a couple of points. Even if you improve the filtering, radios generally they don't have a block filter. We've got these lines on the chart, and we think of them, here it ends here exactly. Well, usually there's a little bit of roll off. You don't want to be something that nobody paid attention to, but there's always limits to what you can do at this point in time to prevent reception of signals outside your band. Hopefully you get it as good as you can, and you're right that the standards are set in a way that we don't have future problems on the other end. The other thing I think that has become more challenging over the years has been this notion of the out-of-band emissions. For many years it was pretty simple. You looked at it as one radio and its emissions that fall into the adjacent band, and you thought about it as well. It's probably like one radio that you're evaluating. Now you've got systems where it's not only a single radio, but it's multiple sources, all of which have control dynamically through the power and through the antenna beam forming, et cetera, et cetera. So these analyses have become really complicated, and the assumptions that go into it. So it doesn't sound very thrilling to be dealing with these issues of out-of-band emissions, but it becomes really critically important because those emissions fall into somebody else's band, and you'll never get them to zero. And we're not going to put cryogenic filters into radios, but it's a tough problem, for people to understand and comprehend, what are the boundaries on what's reasonable and so forth. So I'm going to move on to another part of this. So the legislation didn't specifically mention unlicensed. You heard a little bit before about what the reasons for that might have been, but it seems like all the policymakers recognize the importance of unlicensed and advanced sharing technologies, such as those reflected in CBRS. And I'm not here suggesting that, because there's some issues right now going on about should the power levels be increased, et cetera, et cetera. So I'm not talking about taking CBRS and transplanting it everywhere else. But it's the notion of advanced sharing and techniques that allow more efficient use of spectrum. So any thoughts on where things stand for unlicensed, particularly for future Wi-Fi generations? And what role do you see for advanced sharing techniques? I'll mention here that there was a great report out of the FCC's Technological Advisory Council on broad swath of spectrum up to 24. And the back end of it talked about opportunities for sharing in some of the spectrum outside in the range that we're talking about, but also above as well. So any thoughts on unlicensed or advanced sharing and how this fits in, relative to spectrum generally? I don't think the pipeline was intended to be the only thing that happens in spectrum.
Yeah, I'm happy to start on the Wi-Fi unlicensed front. Right, we're seeing incredible growth in 6 gigahertz Wi-Fi, faster than 5 gigahertz Wi-Fi, and in terms of devices, in terms of usage, etc. So I think as we think about unlicensed, we want to sort of build a path for growth there too. And as we think about 6 gigahertz, the natural sort of growth there would be to extend it up into 7125 to 7250 to round out sort of another 320 megahertz channel for Wi-Fi. And as we've seen from, Broadcom and others recently, as they're thinking about Wi-Fi 8 and Wi-Fi 9, they're beginning to plan for 640 megahertz channels. Broadcom has demoed recently sort of silicon to be able to, take advantage of 640 megahertz channel Wi-Fi. And so to be able to have 2 of those channels, we would need to push up to 7250 to be able to round out sort of 2 640 channels. So I guess as we think about it, it makes sense to sort of plan for that, versus if we reallocate sort of right up against 6 gigahertz Wi-Fi today, it doesn't allow that room for future growth. And this isn't to sort of take anything away from other services and where we put them, but given sort of that ecosystem growing, it in our minds makes sense to sort of at least plan for that extension into the future.
Any other thoughts? What I want to do is we'll move into the questions from the audience. I've got a bunch more questions if nobody. Go ahead, William.
So just very quickly, I think that the whole concept of on license does show up another challenge with the pipeline, which isn't really designed to work with on license, and indeed, specifically is about on shared spectrum. And I think that's just a plain wrong to not consider all of these other options in looking ahead and deciding what the best route is. And it strikes me that we're in a more uncertain future now as to whether we will need continuously more spectrum for the applications that have been growing in the past or not, or maybe military will need more spectrum in the future compared to civil, given what we've seen going on in the world and things with drones. And all those suggest that actually sharing is a better way ahead because it gives you the flexibility to dynamically change what's happening in a spectrum band rather than to give it over to one application for 15, 20 years, which may be the wrong choice. So I do think that the pipeline is missing a trick by not requiring all of the spectrum that's being released to be shared in some way, shape, or form.
Thank you, William. So I'm probably going to need a little help from the room there because I can't see all the folks who are there. And I don't know if we've got a microphone out there. Emily, if we can get questions from the floor, if you want to put it in the chat.
We have 2 mics in the room that some students are going to run for us. So it's like Scott Palo and Manisha have some questions right now.
Yeah, great. Thanks, Julie, for the great panel and everybody for your participation. As we're talking about the pipeline, you hear discussion about the exclusive use and shared use and the applications. One of the things when we think about shared use that wasn't discussed, and be a little provocative here and ask the panel to think about the use for scientific purposes, particularly for the passive users. So we're thinking about here of using spectrum for transmitting, but obviously that then eliminates others from using it for receiving, particularly in the scientific community. So I just wanted to kind of hear thoughts on that and how we're potentially impacting our ability for future discovery.
So I don't know. I'm happy to jump in on that. No, I think that's a great point. And I think, as we think about shared use or unlicensed use, sort of understanding, those abilities to coexist, obviously, going back to 7 gigahertz or lower 7 gigahertz, there's obviously important scientific use in 7125 to 7250. I think it's an open question in our minds of whether indoor Wi-Fi, LPI Wi-Fi could coexist with that. I don't know that question's been studied, but, as we try to think about how we can extract increased value, increased intensity of use, across all the dimensions of spectrum use, obviously we need to consider that passive use as well from a scientific perspective, but I don't think that shouldn't rule out exploration of whether there are abilities to coexist with that.
So Scott, hey, this is Paul Ransom. Certainly as a part of the Assistant Secretary's conduct of the feasibility analysis, it's key to ensure that kind of those radio astronomy uses and those passive sensing uses are protected and can continue to enable the discovery and exploration that's necessary. So as a part of the analysis, NSF and NOAA and NASA and all the science agencies are intimately involved in ensuring that, kind of their locations are protected. There's already been a process between NTIA and the agencies, scientific agencies, to ensure that, those capabilities that, are very important to our science discovery are protected. So certainly a part of the analysis. And, when we look at how we're going to make spectrum available and kind of meet this, the goals of the One Big Beautiful Bill Act, those services and activities will be protected. And, that's certainly a major part of what NTIA does as they conduct these compatibility analysis with the agencies.
So let's move to another question. I don't know if Manisha, did you have one there?
Yeah, can you hear me? Yeah. Thanks all for a very, very interesting panel. One of the questions that I'd like to throw out there is, when you talk about capacity or coverage, we've focused only on the spectrum piece, but along with the spectrum piece comes deployment density. And I recently came across a very interesting report from the European Commission on 5G. They call it the 5G Observatory. And one of the numbers that jumped out of me was the amount of, when we compare ourselves with China or other countries, actually South Korea has 670 5G base stations per 100,000 residents compared to 42 in the US, and they have less spectrum. So the question I have is, when we focus so much on putting more spectrum out there, especially when we're looking at even higher frequencies, we're going upper C-band, we're going 4.4 to 4.9, we're going to lower 7. How does the discussion about density play into this? Because if you don't densify at those frequencies, even you have all your fancy antenna technologies, you're not going to get the same coverage and capacity. And we've done a ton of measurements to show that there is a difference even in C-band compared to, say, 2.5 gigahertz. So I'd like to just throw that out as a comment out there and get some reactions.
I mean, I'm happy to start on that one, Monisha. I mean, look, it's a good point. And I think the operators always try to balance the densification process with the spectrum integration process. I think, it's important to remember too that different countries do siting differently. So we have a number of challenges in the United States with building infrastructure. And it's not unique to the MNOs. I know the cable companies have similar challenges when it comes to access to rights of way, access to existing infrastructure, the right to build new infrastructure. And that has been true from the days of the giant macro towers to the small cells today and whatever it looks like in the future. So I think it's true in the United States, we've probably relied more on antenna technology than strict densification of networks. And I think there's still a push as you move higher in the bands to build the antenna technology that can meet propagation modeling and put out a footprint that matches up as close as possible to existing deployment. So for example, I know our engineers are working with the antenna companies to figure out, can you deploy in 4 gigahertz and even up into 7 gigahertz with, new MIMO technologies and beamforming and all sorts of stuff that makes the propagation and deployment model look a lot like what we did on C-band. It's sort of a push-pull, frankly, when you get down to it. And I think what's important to remember is, not every country addresses that push-pull in the same way. So blanket characteristics on, number of towers in a country or number of base stations in a country versus population, I think it masks a lot of hard work. And, as a carrier, we're pleased that the FCC and frankly, the administration is tackling some of these problems right now. You've got an ongoing proceeding asking a number of questions on how to speed up issues with deployment, along with conversations in Congress on, how to figure out reasonable ways to moderate this tension between, rightful state and local interests in aesthetics and everything else, and the need to get better, more resilient, more reliable deployments out there.
I think that's a great
Yeah.
point. What's interesting is, as NTIA begins to conduct these analysis, particularly looking at 7 gigahertz per se, and Julie pointed it out in the One Big Beautiful Bill Act, it does kind of make mention of full power commercial use, but what exactly does that look like when you're looking at different parts of the spectrum? So certainly as you're trying to do an analysis and conduct the studies, as if you're NTIA, you have to kind of understand what is the transmit power you're going to be kind of needing to work with in order to ensure that you're protecting, kind of missions that, may need to remain in the band, or what does that look like in terms of any kind of adjacent band interference. And so our team is working with kind of CTIA to kind of get a better understanding of what full power commercial license use may look like in a band like 7 gigahertz, to ensure that we're modeling the correct things and taking into account the difference in the propagation as it would be, say, for something in the lower mid-band spectrum. So, to Manisha's point, we have to consider all of that as we look at the analysis, and perhaps there's not going to be a greater densification. Perhaps we're going to look at what full power commercial use may be redefined or newly defined for 7 gigahertz, and then that becomes a part of how we do this analysis to ensure that kind of federal missions and federal systems are protected while making spectrum available in a way that is conducive to kind of the deployment that commercial industry wants to, how they might want to deploy. So when those studies are kind of conducted, I would say as SpectrumX, ensure that you're kind of paying attention, and kind of there might be opportunities for engagements for it with SpectrumX and other entities to understand how we're doing this and maybe kind of contribute.
William, go ahead.
Yeah, so just to sort of, again, take a bit of a step back, the question on densification, as far as the operators are concerned, is purely one of economics. What's cheapest? Is it cheapest to densify their network, or is it cheapest to get some more spectrum and deploy it on the existing grid? And generally the answer is more spectrum, because densification is really expensive. And we see that around the world, that actually there aren't many countries around the world that are densifying. And that's the reason why broadly small cells have been disappointing for quite some time. And I think I'd just caution against comparators like number of cells per subscriber base. If you actually ask subscribers in the US what the most important factor of all from their cell phone is, it comes out as cost. That's what they want more than anything. They want lowest cost. And actually, the comparators there aren't great. So as a guide for you might be interested in this, my monthly cell phone bill here in the UK is $11. I pay $11 a month for my cell phone. I get nearly unlimited use for that. That's a comparator that might be more interesting to look at and ask why the US is so far out of alignment with other countries on that basis.
So at risk, we may go over by a couple of minutes, Nick, if you'll permit me, but I thought this question was important. I'm going to just kind of leap off the last thing that Paul said, and that is, how can SpectrumX best align its research, policy engagement, workforce development, and collaboration activities to contribute to these issues and realize constructive impact? And in asking that question, I'll note that when we talk about sharing, there's all kinds of different kinds of sharing. It's been around forever. It can be static. You do the analysis. It can be, hey, we're going to deploy everywhere, but we know there's going to be a couple of sites that aren't going to bother us at all, and we'll just coordinate with them. I mean, that's kind of what happened with DoD at 1.9, and all the way down to more advanced sharing techs. So the question really, I think that, and I don't expect all the answers to come from the panel or here today, but I think what SpectrumX it will be grappling with these changes, what are the things it should consider doing, to help through all of this? Any thoughts?
I mean, I'll jump.
Question, I get silence on the last question.
No, I was trying to figure out how to jump in because you kind of took my thunder, which was going to be in two ways, Julie. One was going to be the sort of the point you raised earlier about out-of-band emissions, and look, coexistence on the margins is going to be harder and harder and harder going forward. Like regardless of the use cases that are on either side of that margin, whether it's, full power license, whether it's unlicensed, whatever, that coexistence on the margins is going to be hard. And how you deal with spurious emissions, how you deal with out-of-band emission limits and all of that stuff, it's going to be more and more complicated. So, we have often talked about the need to figure out how you have skin in the game on both sides, because we often come up against those challenges most directly when you're dealing with federal systems. So thought processes, research on how you figure out the balance, there's probably a better phrase to say that the balance of the equities on sort of that margin, and how effectively we can deal with those sorts of margin cases and the spurious emissions and filters and all of that. And then the other thing you sort of stole my thunder on was the sharing conversation, which is, look, I know there's good work that's been done on dynamic sharing regimes, and we as CBRS users have been the benefit of that. And even though we're out there talking about how to make more intensive use of CBRS at higher power levels or whatnot, it's become a very important band for Verizon and how we add the extra capacity on the downlink side to deal with our customers today. But I do think, for all of the work that's done on figuring out dynamic sharing systems, I think equal research and time and effort can go into improving static sharing systems, whether that's better compression technologies, better channelization, how you figure out shrinking the geographic exclusion zones when you need to have them or whatnot. Like, there's a lot of complicated issues in all of that, and all of that work goes towards freeing up more usable spectrum for whatever use case that you want to do. And then the last pitch I was going to put in especially as you reflect on CBRS, would be thinking about feedback loops on sharing, how you improve a sharing model once you have adopted a sharing model, and do that on a more frequent basis than we've seen in CBRS on 10 years. But also think about if the underlying assumptions that created that sharing model go away, i.e. lots of conversation going on right now about the Navy radars moving out of that band. What does that mean for that band going forward? Does that mean that we can have a renewed conversation on transitioning that band to a different model? And I know that's something that one of my MNO partners has brought to the table when it comes to CBRS. It's something we're looking at and obviously have questions about as a user, but see the value in having, if you look at that 3 gigahertz band and you extend it up on the extended C-band auction, and you can somehow make better use of CBRS and make it look more like an N77 band, that's a really nice wide swath of mobile spectrum that's, very contiguous, offers wide channels, and is very usable to deal with sort of the capacities that we're dealing with right now. And that's sort of what we're pondering as a company and as an industry is, new bands coming online, but maximizing what we've got out there as well.
Right. And so we've run over a little bit, but if you have some comments on this last question, if you can just keep it down to about a minute, if anybody else wanted to wait jump in. Yeah.
So, I think on the CBRS question, we are not aligned with Verizon on this. We think the band is hugely successful. And I worry that we only think about spectrum policy through the eyes of the mobile network operators. Like, the private network industry in CBRS is exploding, and it is sort of the democratization of spectrum access. It allows folks to build their own networks, leverage 5G equipment to do it, and innovate in ways that we can never possibly have thought of. So I caution, right, through the eyes of the MNOs, we should clear out CBRS and just make it another MNO band. But there are many other users, from manufacturers to farming to airports across the board that are taking advantage of this in new and innovative ways. And we should sort of think about those equities as well. On the research question, absolutely. Like, the intensity of use of spectrum is only going to grow. So we need better tools to think about and understand coexistence. We're still grappling with, clutter and how we should properly model that. NTIA, ITS had a big workshop this past fall on that. There are huge questions about, as that intensity continues to grow, we're going to rub up against sort of boundaries in ways that we didn't previously think about, and our tools our historic tools couldn't grapple with. So absolutely, like we need better tooling to be able to manage this greater intensity of use.
Right.
And
Go ahead, William.
quickly from me, I think actually what the bill has done is it's ruled out a couple of the most promising looking frequency bands, the lower 3 gigahertz, which clearly could be potentially used quite easily for reasonably good propagation. And the 7 gigahertz, which was one of the bands that was put forward as perhaps the primary possible global 6G band that people might coalesce around. I would say actually some research into how those bands could be shared with potential defense usage such that they could be brought back into play potentially would be really valuable.
Right.
Just had one thing to
Well,
offer, the One Big Beautiful Bill Act also required the Assistant Secretary to, and you mentioned it earlier, to produce these biennial reports on the value of spectrum. Value is not defined in the bill, so it doesn't simply just mean what an auction might, achieve from, a particular portion of spectrum. It is the value, totality of the value. It could be the value in terms of societal benefits. And I think that that's a very, very much an area where we, NTIA, would like to engage with SpectrumX on helping us to understand how we might just, kind of define what this value means and develop methodologies and approaches to kind of support what value might mean as we start to, kind of go through and look at these reports. So just putting that out there as another area where I think there is lots of opportunity for SpectrumX to engage with particularly NTIA on.
So with that, I'll just make two very quick points for the students in particular. If you continue on in this field, it will never be dull. And hopefully what you got out of the panel is it's complicated. We need a lot of bright people to help us solve these problems. And with that, I will wrap it up and thank all our panelists and the participation from the audience. And Nick, I will turn it back over to you.
Thank you, Julie. And thank you, Mark, Paul, William, and Shawn. We just snapped a photo so you could appreciate how full this room is and how attentive they have been the entire time. So, and hopefully you will hear us giving you a round of applause. Thank you.